All right, hey everybody, this is our last part on specifically on functions. It's 1.4, and we're talking about evaluating functions here, which really is evaluating functions for values. This is where we start to play with math with these a little bit. So function notation we mentioned in an earlier video is when we use this notation of f of x instead of y. And so this is an example of what a function might look like. This is a linear function. And again, I'll just share that we use f of x in place of y. And we say it as f of x or a function of x. That's the language we use. And really, this is just a thing that mathematicians like to do. There's no real good reason. The math isn't any different. There's no different rules with functions when you're doing algebra, but mathematicians like to make it clear when something is a function or not, and so we also need to learn to make it clear. So I've kept this x in pink to show that really what this is telling us is it's defining a rule about x. So this tells me that I have a function, and the function takes an input of x. And then what it does with my input is it multiplies my input by 3 and adds 7, and this will produce my output. So I put in an x, that's what this tells me, and whatever comes out here, that's my output. So a couple places we'll see this. The reason we'll see this is because we'll be given equations like the following, where it'll say, I have a function that does this. So I have a function of x that takes x times 2 and subtracts 5. So that's a definition of a function. It's another linear function. And the question we might get is, what is f of negative 3? What is f of negative 3? And again, remember that when we have something in these brackets, that's our input. So this is saying, what happens if I plug in negative 3 for x? So the way I think about this is it says, what happens if x equals negative 3? How am I going to solve this? This is how. I'm going to write and say, okay, I know I want to take a function of negative 3, and I know my function looks like this. It has 2, it multiplies it by my input, and it subtracts 5. And wherever I see that x, I'm going to replace that x with my negative 3, so it's consistent. So f of x equals 2x minus 5. F of negative 3 equals 2 times negative 3 minus 5. So I'm plugging in whatever's in here into my x. And I like to make it really clear by putting in brackets so I'm not thinking it's a subtraction or thinking something nuts is happening. And then I'm going to solve. 2 times negative 3 is negative 6. Minus 5, that gets me negative 11, and so I can say confidently that f of negative 3 is equal to negative 11. You can kind of do that mentally too. If we know our function times is by 2 and subtracts 5, I can say 2 times negative 3 is negative 6, minus 5 is negative 11 to make sure my work makes sense. So let's do a slightly harder one. Sometimes we see functions with different letters. So this one, we're going to actually say the function's name is g, and what it does is this. Function g takes x, squares it, and subtracts it. So g of x, or g as a function of x, equals x squared minus x. And I might want to know, what is g of negative 1? What is g of negative 1? I'm going to keep this in green because I always like having those colors. So how I'm going to do this is I'm going to start by writing, all right, g of negative 1 must be equal to, that's where my x is, squared, minus another x. And where I have that x, I want to put a negative 1. So g of negative 1 is negative 1 squared minus negative 1. And again, to make sure that I'm not dropping negatives or doing something funny, I'm going to put everything in brackets so I always have a placeholder to plug in my x value. Now I'm going to solve. -1 squared is +1, minus -1 changes to +1, and I get an answer of 2. So g of -1 must be equal to 2. So when I plug in -1, the output is 2. Input -1, output 2. The last example I'll do is also with some different letters. We're going to take h this time, and instead of x, we're going to use a, because why not? We can. Some people will do that. Some problems will do that. And we'll just do another linear equation where h as a function of a equals 5a plus 7. So a is my input, 5a plus 7 is my output. And my question is, what is h of x plus 2? And you might be thinking, wait a minute. We have a in our function. Why is there suddenly an x here? And so this is where we get into some weird things with functions, which is sometimes we actually plug in more than just a number into our functions. We plug in variables, we plug in just like general math ideas. We can plug in different things other than numbers because our inputs can take many forms. But we still do the same process. We're still going to say we have h of something equals 5 times that something plus 7, right? That's the structure of my function. And then I'm going to say, okay, I know my input is x plus 2, so I'll put it into my brackets. When I solve this, I want to distribute and solve just like normal. So I've got 5 times x and 5 times 2, which gives me 5x plus 10 plus 7. And I can combine my like terms and get 5x plus 17. So I know that h of x plus 2, h as a function of x plus 2, gives me an output of 5x plus 17. And it's weird, but we can't simplify anymore. This is our output. This is what happens when we plug in x plus 2. All right, that's it for evaluating functions. We'll do a lot of practice of these. Just get used to this idea of being really careful when you plug them in. I love using brackets. I write them really carefully, even now, even though I've done this for 20 years. That helps me when I have variables. It helps me when I have negatives. And it just helps in general to keep my work clean and readable and good for later. All right, team, have a nice one.